one. All right, one, it's April the 4th. All right, so first one, we have swapping nodes. All right, I'm gonna handle this and then handle the hot question from the contest. I didn't even look into it, so I'm not sure how difficult that one is. Okay, so swapping nodes in a linked list. You're given the head of a linked list and an integer k. Return the head of the linked list after swapping the value of the kth node from the beginning and the kth node from the end. The list is 1 indexed, so it's 2, so 1, 2, 1, 2, and I swap the node. So all I need to do is find where the node is and then do the value swap. Okay, how do I find the value? It'll be easy to do this way. Right, I can find this one very easy because it's 1. So I just basically moving k minus 1 times. Then I hit it. Or I put a dummy at the front. Yeah, we put a dummy at the front to move k times. Right, move k times. So that's that. And we need to find this. So that will be, say, 1, 2, 3, 4, 5. Right, 5. So k. So if that's 2, 1, 2, right? So it will be total number minus k. 4. No. 5 minus 2 is 3. 1, 2, 3. Oh, right here. 1, 2, 3. So start from here. Go 1, 2, 3. So now we need to know the total length. All right. So the question is it possible to not know the total length? I say the easiest way is to know the total length. I'm gonna know the total length. There probably are easier way to do it, but what else can you do? Well, what else can I do? I know the middle, right? Oh, how does that help? Well, if I know the middle, I still need to know the total length. Screw it. Let's just do it this way. And then we check the results, see how, let's say, a smarter way is. We don't know what's the smarter way. Now, I don't expect this to be too hard to code. Yeah, we're not gonna test anyway, so it's fine. All right, so what are we saying? Well, what we're saying is we need a total, right? So we need a length equals 0, right? And then node equals head, right? While node length plus equal 1, node equals node.next. All right, once we're done, and then we from node, we're gonna move. I'm gonna just do k minus 1, right? K minus 1, and then 1, 2, 3. So it's length minus k. So we say, count is going to be k minus 1, and then node 1 equals head, while, we don't have to while, we'll just say while count, right? Node 1 equals node 1 dot next. Right, so k is 2, 2 minus 1, so this is 1. And then, so no 1, no 1, and then minus equal 1. Count minus equal 1, and be 0, come out. And then we do it again, right? Do again, this is going to be length minus k, and node 2, okay? Once we're done, we're going to say node 1 dot val, node 2 dot val equals node 2 dot val, node 1 dot val, and return head. Oh, it should be right. All right. Yeah. I mean, the only thing that might be issue is just slow. All right, let's edge case, right? What else? We use this. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. How about 9? Oh wow, well, it's done it in the past. Okay. All right, let's see. I'll just use previous, and we don't have to read the solution. These are the solution I read in the past. So this will be a very naive, should I say, naive way of handling this. $17.21. Well, this is the naive way of handling this. Find the total length, and we know where the kth node is from the left and from the right. Call it ON. 1750. Oh, that's actually pretty bad. 20%. All right. Any smart method. So this was the previous one. Oh my god, what the hell? What? Left and right adjacent? What was I doing? I have no clue. This looks terrible. This looks terrible. I don't like this. How about this one? Post left, right, post right. What was I doing? The hell? Oh, I was trying to do a one-pass solution. Oh, I think I was trying to do one pass. Pre-left and the left. Oh, I didn't swap the values. I swapped the actual node. Yeah, that's fine. Wait. Wait. This one go. Hold on. Wait, that's probably a requirement, right? A requirement to use it. No, there's no requirement. Oh, it's this. So I go pre-left, left equals okay. And then pre-right and a right in the front. Pre-right equals right, right equals right down next. No equals no down next. Oh, I think I know what this one is doing. Yeah, whatever this is, I don't like it. But this is interesting. So what it's saying is, I find K, right? Yeah, I have K. And then I keep going forward. Right? I find K and then keep going forward. I find the K. Node equals left. Okay. And then we're gonna go all the way towards the end. So we go here, right? And then we have this node go all the way to the end. From here all the way to the end. And we only go, and then we have another node starting from here. So on this one at the end, this one, oh, one pass. I see what happens there. So this is one pass. All right. I mean, first of all, we have to arrive here, right? So we have one node arrive here, and then we start from the front, and then we go 1, 2, 3, 1, 2, 3 towards the end. Okay, so what do? We need to have node 1 equals head, and count equals k minus 1. All right, and a while count node 1 equals node 1 dot next, count minus equal 1. Okay, so this one will have node 1 ending here. All right, so now we say node equals node 1 and node 2 equals head. Okay, so node 2 starts from here, node 1 starts from here, and then we just keep going. All right, so we go, because they differ by k, so whenever this one hits the end, so then we say while node dot next, node equals node dot next, node 2 equals node 2 dot next. Okay, once we're done, we do this and return head. Yep. So one pass solution. We first locate node 1, locate the kth node from the left. Then we start a new node from the beginning and a temp node. How do I say it? We first locate a kth node from the left, call it node 1, right? Then we start a new node from beginning and a temp node from node 1. Have the temp node and the new node move in sync until the temp node hits the last node. Then and start node 2. I call it node 2 and node 2. Then node 2 will point to the kth node from the right. Yeah, when one pass. That's pretty good. Yep, it's faster. All right, that was that. Oh, we still have some time. All right, sum of scores of built strings. Now, people don't like this one. You are building a string of length n, one character at a time, prepending each new character to the front of the string. The strings are labeled from 1 to n, where the string with length I is labeled si. So for example, s equal this is 1, s2, s3. So we prepend, okay? The score of si is the length of the longest common prefix between si and sn. What the hell is this? The score of si is the length of the longest common prefix between si and sn. Note that s equals sn. The length of the longest common prefix given the final string as return the sum of the score of every si. Alright, I gotta see the example. I don't understand. S1 is B. The longest common prefix is B, which has a score of 1. What do you mean by common prefix? Oh, this is B, and this is B. And now we have AB. There's no common prefix. Now we have BAB, and we have BAB is 3. ABAB is 0. 5. Huh. Okay. Z is 0. AZ. Okay. AZB, that's AZB. That's 3. The last one is 9. Ah, I see. 10 to the 5th. Cannot do, I think the most we can do is O(n) log n. 10 to the 5th, no O(n) squared. You're saying we're gonna build a trie for this? I don't know. A, Z, B, A, Z, B, Z, A, what was the last one? Z. Well, no, Z has no prefix. AZ, okay? And we're looking at AZ, and we say, how do we see AZ? Then we compare, right? We say, okay, AZ we have. Okay, so we have, and now Z, no good. B, no good. Z, no good. Now A again. So we'll go A, right, Z, and B, and then no. I think that will cause memory. That will definitely cause memory exceeds memory. 10 to the 5th. Yeah, see, 10 to the 5th. Even like string bits. Now I think no, it's not gonna be like the prefix. But if we do prefix, we will try. It doesn't help because we still have to check one by one. Like given a string, I want to see how long the prefix has matched, right? Or the prefix has matched. Yeah, it's the same prefix, right? It's the same prefix. So that's not what where try excels. Try excels if we have different prefix. But now we have only one prefix. So using try or not using try is the same. And if we compare one by one, that's O(n) squared. Right? That's O(n) squared. That's not what we want. That's not what we want. So maybe I can, So we start from A, right? Let's see how many A's are there in this string. And then we see, okay, A is in the front, and we have A here and A here. So the only possibility to score is at these positions. Okay. Now we have reduced the problem to these areas. I mean, we don't have to really do the front one. The first one is definitely gonna score. So we just, in this case, we only have two candidates, right? Now we check the second one, Z, right? We check Z, and we just go from these, we look at the second one, Z, right? And then they all have, and whenever they don't have, we can make the score. All right, but I can see if I have like say A, like all A, things like that. If you do this method, we're gonna have all of them, right? And check the next one. Everybody has to check the next one. Everybody has to check the next one. There's no end. There's no end to it. That's still O(n) squared. I'm still gonna time out because of this. How do we handle if we have bunch that have the same value? If a bunch have the same value, yeah, it's 1 plus 2 plus 3 all the way plus. And that's not what we want. if the prefix is equal to something else, okay, what can we say when we extend? Think about it. So we have some match, right? We have some match. We have a prefix and blah 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 blah, and then we have this and blah blah blah. Doesn't matter. So we have this and this. They're matching. Okay, so the prefix matching. So in this case, they match for this much. Then we add the score. Okay. So now I add one to the front, considering the string on the back, right? We add one in the front. And in order to match, we need to say, because we know this and this match, right? So these are matching. Therefore, if we want to match the new one, right, we need to see, take the front out, is this part, whether this part matches this part plus this, right, matches this thing, whether they match. Hold on, let me try it again. So I have, let's say, this, something, this, something, right? And then if I want to include one more on the front, which means this one has to match. Look, if this doesn't match, then there's nothing. We have to keep going. But if this one does match, then we need to check the remaining, right, need to match this. But what we know is the remaining is matching these, right? So these are matching. These are matching. I mean, what we can do is so we know this and this does not match. We know this and this are matching, and this is not matching. They do not match. Okay. But now we want to see is this and this whether they match. It's completely shifted. If these two are the same, these two are the same, these two are the same, what can we say about this and this? Right? Yeah, so the thing is, if we say A, B, C, D, and A, B, C, D, okay? So let's say in this scenario, and then these are matching, and then we want to include a new one here, right? Once we include a new one here, what the requirement is this has to match this, and we need to have BCD matching ABC, right? Which just means that if, because we know this matches this, right? Now we want to try to see if this and this match. So basically it's just this and this. If A and B match. If A and B does not match, then this will never work, right? It will never work. So what we're saying is, so this can never match, and yeah, so we can go say 2 at the front. So if we go 2 at the front, then the requirement is for this thing to match C, right? So if these two match, if these two doesn't match, then it's not gonna work. So we have to keep moving forward, and then it will be A matching D. It doesn't match, so keep moving forward, and then we are matching this. So now we have a completely fresh start. I will have a complete fresh start. I still don't feel right. I don't know. No idea. I feel like maybe dynamic programming. Like, let's say, okay, change mine. Let's don't go from right to left. Let's go from left to right, right? Let's go from left to right. So I say from the start, everything's matching. That's not interesting. And then one from the first spot, and then the other from the second spot, right? So we have just shifted, right? One shifted, and we want to see the one shifted, how much can we match? Okay, so one shifted, I have this. Basically, I have this substring and this substring. They are differ by the first one. Okay, so if the first one doesn't match, then we just keep moving on, right? We keep moving on, until, let's say, first one match. Then what? Then we check the second one. Okay, we check the second one, and we keep checking. Okay, so after I finish, let's say we have this much and this much, they match. Okay, and the remaining doesn't match. Okay, so the front match a certain amount and the remaining doesn't match. Okay, so that's what we know. They are exactly the same. And these are also not matched at the front. So this part and this part are matching. And then we need to start from this position. Okay? And what do I know? Whenever they match, right? And then if we move to the next spot, because I know, so this is the repeating situation, right? Because the start is a full and a full, right? And then I experience a couple of no match, right? And then boom, I hit a match again. Okay? That means because initially I have a full match and then I start moving and then there's no match, right? No match. So no match. And then suddenly I have a match again. So now these value and these value match again. So if I keep shifting right, we're going to experience the same no match, no match, no match, no match until so at least certain amount, right? At least certain amount. And now it depends, right? Because initially it's a full match, and then the next match, right? We want to see when the next match happens, right? So the next match happens, and also how long it matches, because initially it's the entire thing matching, right? And now we go step by step, and at a certain point, let's say I matched again, okay, and then we can actually keep moving forward to see how long I have a match. So I have certain what, because initially it's a full match, right? So from the full match, the first to the second match, that distance means if, so no matter what, like if your matching is, even if your matching is full, you will have to go through this bunch that you cannot match, right? You have to go through this bunch you cannot match, because initially it's a full match, right? And I move forward, no match, and boom, I have a first match. That means, oh, it also depends. No, it doesn't depend, because that's the entire prefix. And now you have a prefix, and you just shift, shift, shift. And the first time you hit a match, right? You have this match, and then even if you have a full prefix match, you have to move, let's say, at least 10. So like, let's say you have 100 in length, right? And you have to move at least 10 spots to hit the next match, which means even if you have a full match, you have to move 10 spots to get the next match, right? So the 10 spots is the minimum you have to, the maximum you have to jump. So now you count how many matches you have. If it's longer than 10, then you have to jump forward 10. If it's smaller than 10, you jump forward a smaller amount. I have an idea, but I need to stop right here because I have other thing coming up. So we'll continue this, right? We'll note it down as I have an idea, but we'll continue on this tomorrow. All right.